Hello, everybody. Good morning. Please confirm you can hear me so that we proceed. And that you can see my screen. Hello. Hello. Can anybody hear me? Hello. If you're speaking, your mic might be mute.
Yeah, I can hear you.
Look,
I said I can hear
okay, I
you.
wonder why every other person will... Yeah. Thank you so much for your response, bro. Thank you. All right. Let's start. The latecomers will use the recording, so I don't waste too much time. Yes, so during the last class, we started talking about execution context, JavaScript, which sometimes could be a very technical topic to discuss, but with time it gets easier. So today, during today's class, we'll be strengthening the knowledge you already have on the topic. Then, well, concepts like
British design from a Korean brand. I love it. There was Volvo design. There was Mercedes.
Sorry, I can't hear anything anymore. Am I doing one?
I can hear as well. Hey, Baba. Time. Okay. What are okay. Vamos tomar daqui.
Are we still having this class?
Please let Ayodele mute his mic. The background noise coming
Okay, sorry, please. Sorry.
Ayodele, can you mute your mic, please?
Hello, guys. Please confirm that you can hear me now.
Yes, we can, sir.
Yes, I can hear you.
Yes.
All right, great. Thank you. Okay. So as I was saying before I went off, when you load, just a recap of the last class, when you load a file, a JavaScript file into the JavaScript engine, you are going to get the global execution context, and as default, like that's the first thing that happens, right? It is created for every program that you run. And then on top of that, you would have your function execution context when a function is called, okay? So I think we visualized it on the call stack like this. So remember the call stack, uses the first in, last out principle. So it looks like this. It's, yeah, so this is how it looks. So what you have is the first thing that gets created, of course, is the global execution context, which is called anonymous in the browser. So I'm just going to say anon. Let's use it like that. And then the second would be the function, and it's usually named after the function that was called. All right, so let's say you have your say hello function. That's what that guy will be named in the execution context. All right, sorry, in the stack. All right, in the core stack. So every execution context gets into the stack. All right, in the order in which they were called. And they are going to be removed from the stack, in the reverse order. All right, the first guy gets removed last. All right, so let's visualize this using this tool. All right, you can find this tool online. It is called latentflip.com/loop, LOUPE. So you can get that online. All right. So I'm not going to talk about every aspect of this tool today because we're going to do that another time when we start talking about asynchronous JavaScript. All right, then we'll talk about some of these other things so we can understand how JavaScript runs asynchronously. But then you can go ahead of me and even learn it. All right, so that when I teach, it will be easier for you to understand. That's why I pinned this video here so that I can share with you guys. Leave it in the call in the chat. So you can see both links in the chat. All right. So this video is going to explain exactly everything happening here. All right. And I'm sure you'll be glad you did watch it. All right, so let's go. I have a function here. So if I decide to just run this program, unfortunately, the way it was created is just going to not do anything. All right, so what I'll do is I'm going to write a function, call it say hello, and then that function is simply going to console the log hello. All right. And then I'm going to call the function say hello. Let me try to zoom in. Let's see. Okay. Call the function say hello, and when I run, you're going to see say hello printed in the console. Say hello added to the call stack, and then another thing gets added to the call stack, which is console the log function. Actually, the log function gets run in the call stack. And if you think about it, let's run it and let's rerun and pause. All right. So if you think about it, from line 1 to 4, according to what we explained during the last class, this is a function declaration. All right. That's a function declaration. So what happens is that it's going to be taking note of during the creation phase. All right. Executions happen during the execution phase. Okay. So during the creation phase, the JavaScript engine takes note of this guy, adds it to the memory heap. It's aware that there's something like this. All right. And during the execution phase, that's when it actually gets executed. Okay. So it makes sense that we don't see any action until 5 because that's when the execution takes place. All right. So I'm going to save and run and pause. So we see that line, at this line 5, all right, say hello is popped in the stack, or is pushed into the stack, all right? So I have say hello here first, and then during the execution of say hello, the JavaScript engine encounters another function. What function is that? That's the console.log line, all right? But the name should be log actually, because the log function is what's being executed. And then it is pushed into the call stack, all right? Now, if you look at this, you would agree with me that this function is going to be called first, right? That means the execution of this function, this log function, is going to be done before this say hello will be considered done, all right? That's the reason why. So if I resume, you see that it gets popped up first before say hello gets popped off. Okay, so that is that. It means that if you have a function still in execution, and then while that function is still in execution, another function gets executed, the new function is going to appear on top of the currently executing one, like the previously executing one now in this case. And then the new function is going to run completely. Then execution will come back to the previously executing function, and then and so on and so forth. That's how it works. Okay, so we can clearly visualize this in the browser. I'm going to copy that code, and just try this in the browser. So I have say hello, and I'm going to pause execution at this point just before the function gets removed from the call stack. And then I'm also going to pause execution just before the global execution context is removed from the call stack. All right. And should I pause before say hello? So let me pause before say hello is done. So let's see what happens. All right. So I'm going to refresh, and then you see the execution pauses here. All right. And what do we see? What do we see in the call stack? We see just anonymous, right? I told you that anonymous is the global environment, all right? So that is anonymous. And if I play, the next thing that should happen is that this is line 6, right? It is paused in line 6. All right, if I play, we'll go to line 7. And what happens at line 7? At line 7, we are saying invoke this function called say hello. All right. And what happens? That means that the control flow is going to go to line 2. And then after line 2, it's going to go to line 3. So let's play. So it goes to line 2. We check, you see that the console log statement has been printed. All right. This is the one that was printed now. And then if we go back here, you see that it has paused. All right. So if we check the call stack now, you see that say hello, which is this function currently being executed, is now the currently active context in the call stack. All right. But notice that immediately I play, after line 3, this function is done executing. It means there's nothing left for this function to do again. It is the lifespan has been reached. And if I play, so it is popped off the stack. So you don't see it in the stack anymore. Without this debugger being paused here at the global execution context, you wouldn't see this too, because at line 8, from line 8, there's nothing else that has to be done again. So if I play, see that it's popped off the stack, right? So this is going to lead me to the concept of scopes in JavaScript. Scopes in JavaScript, lexical scope of JavaScript. All right. So what is scope? A scope is a sphere of relevance, if I use that word. So you say that the scope of your permission is simply level 1. Let's just say level 1 is a scope, all right? And what does level 1 entail? It means that you just have access to the reception, all right, of an office, for instance. You just have access to the reception. So that's your scope. Okay. Another person might have access to everywhere in the office, all right. That's a very high scope. So scope is just like a sphere of reference, if I can use that term. So in JavaScript, we have block scope and function scope, or block scope and function scope. Okay. So function scope is the easiest to just explain because it's a function, right? Anything inside the function is in a function scope, and anything in the block, so it's in a block scope. And sorry, I missed out one, which is the global scope. All right. So let's see how this looks like. So if I say const pi equals 3.14444. So maybe some posting maths, they just log out. So let's just do something easier. So I just say let age equals 45. Okay, but we can avoid maths here. But for now, so that this concept is driven home. So let age equals 45. All right, this variable is created in the global scope. Why so? How do we know that? We know that because it is not enclosed within any two curly braces like this. All right, when it's not an object, please take note. When it's not an object, and then it is not within any two curly braces, it is in the global scope. All right. So if I happen to put that variable, create another variable in here called age to say 45, you will notice that we have no error. So if I go back to my console, there's no error. Why? Why is it not shouting error? Because these two are in different scopes. All right, they're in different scopes. This is in the global scope, and this is in a block scope. Take note, this is in the global scope and this is in the block scope. All right. If I decide to pause execution, let's use a debugger. Now, please notice most of my videos up to this point are concept videos. All right. So stay with the concept, try to understand the concept, and don't try to battle with some applications for now. All right. When we start applying, don't worry. You'll see application and you'll be glad. All right, so just giving you the concepts for now. All right, so if you look at this, we're in the global scope. Okay, if I play, you're going to see that something appears here called block. We're now inside a block. All right, so this is a block scope. This is a block scope. All right, so age resides inside a block, and that is its scope. All right, so it's as simple as that. So if I say, so let's make this guy 100, and watch now. I come to the global space, right, and then I'm asking for age. Note that this console log statement is outside a block. It's not in any block. All right, it's outside the block, and I'm asking for age. All right. If I refresh, we should see that we get 45. All right. Why so? We're getting 45 because this is out of our reach. All right. We cannot reach this variable from the outer scope. All right. We can't reach it from the outer scope. So when we ask for age, we get this guy. If there is no age defined here, then we get an error. Reference error, age is not defined. All right, because we are asking for age in a scope where it's not declared. So let's just think very naively for a second. So say I'm in a house now. We have 2 rooms here and a parlor, and the scope of my reach is this room where I'm in now. All right, and then I want to refer to somebody called Jack. All right, and I say Jack, and Jack happens to be in the other room. All right, my scope is this room. So when I say Jack, because Jack is not in this room, Jack doesn't respond to me. Of course, you know that I would shout and then he would hear. So that's why I said, let's think naively for a second. Just imagine that he wouldn't hear me. All right. So if I say Jack, because Jack is not in this room, Jack cannot hear me, therefore he cannot respond. That's why we're getting an error here. There's nobody that can respond to us, all right, that has the name H, all right. But then if I happen to have the door open, right? Let's say I have this door open and I say Jack, and Jack has his own door open. Jack should be able to hear me. All right. So in that case, so let's not even go to that scenario yet. Let's say that if Jack were to be in this room, all right, Jack would have heard me. So in that case, we have our age in the same room or scope as this our call. All right, and then we can see, we can get access to it. Okay. So that is blocked scoping for you. But then there's something that you need to be aware of, right? If I refer to a variable from an inner scope, JavaScript is going to check that inner scope first. And if that variable does not exist in that inner scope, JavaScript goes to the enclosing scope. All right. So what does that mean? So if I take age from here and I come here and call on age, what JavaScript will do is it's going to check this scope here and it's going to say, is age available here? And yes, age is available here. All right, that's good. It gives me 100 because I'm calling age where age is available. But then if age is not available in this inner scope, what JavaScript does is JavaScript is going to check, is age available in this scope? And the answer is yes. All right. And it prints, no, the answer is no. And it says, oh, do we have an enclosing scope? Yes, we do. Okay, check if age is available there. And it says yes, and it gives me 45. All right. So that's how JavaScript works. So let's think about this how do you call it, graphically now. Okay. So the outer space, right, where you have no curly brace is called the global scope, and you're always going to have a global scope, okay, just like your global execution context. So I'm going to represent that with a big circle where we always have our global scope. Okay, so where we always have our global scope, always. All right. And then any other scope is going to be inside the global scope, because every other block you're seeing or function or anything is going to be written inside this file. I mean, so they are all going to be created in the global scope. All right. That's why they are all going to have access to the global scope. So the global scope is like the parent, and every other guy you have could be a child of a global scope, right? It could be subscope inside the global scope. All right, so I'm going to draw 4 circles to represent scopes. Okay, and this could be say hello. So the say hello function creates its own scope, but then it lives in the global environment. And then we have another function that we'll call the greets. Okay, and then we have another function called add. Okay, and then finally we have one function like this that we call let's just call this print. Okay, let's just call it print for lack of names. So sorry, I'm gonna print and bring this guy and put it here. All right, print. And then inside of print has another function inside of it. All right. So that function is inside of print, and then it's called tell. Okay. So you see how this works. Now, if we're inside tell and we need access to a variable called x, so let's say let x equals 12, for instance. X is created in the global scope, as you can see, all right? So if, say, inside say hello, we need access to X. What will happen is that JavaScript will first check. We have a variable called X inside say hello. If we do, it's going to return that variable to us. If we don't, it's going to go to its outer scope, its immediate outer scope. All right. And what's the immediate outer scope in this case? It is global, because say hello lives in global scope. And then it will give us X as 12. All right. That's if X does not exist inside itself. And then same thing applies for add, same thing applies for grades. And when we come to print now, we're trying to access a variable inside print, not inside tail now. All right. Print is an environment that has tail inside of it. So inside of print, we want to get access to X. JavaScript still is going to look at print to see if there's X. If there's X, it's going to return that X to you. If there's none, to go up the scope chain, and it would look for X. If X is there, it returns that to you. Now let's say we're inside tail and we're looking for X. All right, so this is what I'm going to write. So we're here in tail and we're looking for X. All right. Now let's say X is here. What happens is that we all know the inner X is going to be returned. But let's say X is not in tail, but X happens to be in print. All right. So if X is not in tail, what happens? The immediate outer scope, or the enclosing scope, the immediate excluding scope, which is the parent, if I'll use that term, that's what will be checked. And then when it's checked and there's X there, what happens is that the value of that X gets returned to the function. And then we don't check for any other one. But then let's say X does not exist there. What happens is that tail is going to check there and it's not there, and it goes to the next scope, including that scope. So that's how the scope chain works. All right. So the scope chain works like that. From inside to outside is accessible.
Please, can you come again? Can you repeat when there is X inside the tail?
Okay, so when there is X inside tail, you're going to get that X returned to you, right? But then when there is none, it's going to ask its parent, do you have X? And if it does, it's going to return from the parent. If it doesn't have X, the parent doesn't have X, it goes to the grandparent. Do you have X? So think about it like a family tree. A naive child trying to ask the father, oh, do you tell me the story about our community? And the father says, oh, I don't have that information. Please ask your grandmother. And then the child goes to the grandmother. So that's how it works, right? But it never skips one enclosing scope to the outer one. It's going to ask every scope incrementally. All right. So it wouldn't go, the child will not go directly to the grandparent to inquire for something. It's going to ask the father, and the father doesn't have, it goes to the grandmother, or that's the grandparent. Grandparent doesn't have, it goes to the great grand, and like that, until nobody has it. That's when you get reference error returned. All right. There's a scope that has what you're looking for. You are going to get the value in that scope returned to you. Okay. So that's the concept of scopes in JavaScript. All right. It's called lexical scoping because of it's going to be based on the physical arrangement of the code. All right. So that is it. So when you hear that the global scope is accessible to everybody, this is what it means. All right. Technically, this is the explanation of why the global scope is accessible to everybody. Why? Because the global scope is the enclosing scope to every other scope that you have in a program. All right. So if you happen to attend an interview now and they ask you this question, it's a very simple question, but it can throw you off if you've never thought about it. All right. If somebody asks you, why is the variable in the global scope accessible to every other scope in the program? You might be like, because it is the global scope. Well, that's not the answer. Technically, that's not the answer is because every other scope is enclosed by the global scope. That's the last point of call to check for any variable before the reference error is returned. All right. So let's go back to our program and see.
Excuse me, sorry a bit, Auntie. I want to ask, is that why when you want to define a variable in the global scope, it's not advisable you use var or const? It's better we use let.
Okay.
I'm just
so,
trying. I want to
So
understand.
that was the next thing I was going to say. All right. So I'm coming there. All right. So let's come back here, right? You see, I'm using let, all right? And if I use const, it will be the same consequence, all right? So just think of let and const as brothers in this term, all right? If I had used var, there would have been a problem for this particular case, all right? So var does not support what is called blocks. var only recognizes the function scope. So what I just showed you now is even just block scope. Even if function scope is block scope too, right? Technically, but the introduction of let and const, made a separation, right? So var would only support function scope. That's a block scope that is created by a function, all right? var would only support that. But if I put var here, say var age equals 45, then come here and say var age equals 100. And then I'm trying to access var. Let's see what we get in our console. Fresh, we get 100. Let's change it to let so that I see the difference. Let age. You see that we get 45 when we use let. But when we use var, we get 100. Why? Because var does not recognize block scope. This is a block scope, it's not a function scope. So to var, this guys does not exist. This bracket here still does not exist. And remember that var allows you to declare variables twice, right? It just uses the latest declaration as the true one, right? So that's why you get 100. All right, so that's a simple explanation. Okay, so I think there's a build-up of why you shouldn't use var, why you should avoid var. All right, so that is var for you. Okay, so if I did something like this, if age greater than 40, create a variable called name and let it be equal to Justin. All right, so if I save now, say name, I'm looking for name, I'm saying name. Oh my God, name. Save, and then you see Justin printed. How come? Justin is inside the block. Remember, var does not recognize block scope. If I change this to let, then I should have a problem. Oh, it worked. Okay, so let, yeah, that's true. Sorry. Let is going to recognize this scoping. All right, yeah, that's true. Kind of funny, but that's what JavaScript does to us. Let is going to recognize this, okay? Let is going to allow this slide. That's what I mean to say, okay? But I want you to take note of this. So I'm going to do a follow, right? I'm going to do follow, and I'm going to say var I equals 0, and then say as long as I is less than 5, right? I plus plus. All right. So what happens here is also the Lord. In fact, I don't need to do anything there. Let me do var I equals 5. All right, so now I'm looking for I. So you see that 5 is printed. All right. 5 is printed to us. That's after this. So let me do minus. I think this explanation is gonna cause a problem. So what will happen is when we encounter this, I'm going to explain it to you guys. I've already foreseen the issue, but one thing you need to know is this var I is leaking out of this scope. All right, that's something you need to put in mind, because var is problematic with any scope that is not a function scope. All right, take note of that. Any scope that is not a function scope is a block scope. It's just an ordinary block scope, and var will not recognize this. All right, so because of this mental workload that people have to do when they are making use of the var keyword, they just avoid it altogether and just use let, which is something that would not give you. So with let now, this variable and this variable are different. All right, this exists in this block scope, but this exists in global scope. But when I was using var, both of them were like in the same scope. All right, but you wouldn't see an error because, of course, var allows you to declare variable multiple times. All right, so that's it. Yeah, if that, I know a lot of persons might have picked on the explanation, but if you did not, don't worry, be rest assured. When we encounter something like this during a program, I'm going to bring it up. I'm going to relate it to this concept, and then it will become clearer to you. All right. So that is that. I will take questions before I move into callbacks. Before I move into callbacks, I'm going to take questions because we're about to delve into the realm of functional programming a bit. So if you have questions, please, let's have them.
Hello, can you hear me?
Yeah, I
Hello.
can hear you.
Okay. Morning and good afternoon. So thank you for the class. My question is, what is the best practice for when you're declaring variables, especially if you have a function and then you have conditionals, nested conditionals inside that function? So what is the best way? Do you declare the variables as a global scope and then assess them inside the function and the conditionals? So, or how do you do it? What's the best practice for doing it? Hope you understand my question.
No, I don't.
Okay, okay. For example, if you have a function, now inside that function, the function is already has a functional scope. Then inside that function, you now have an if statement, which has its own scope as well, a blocks scope. And then probably you have an else if as well, which also has another blocks scope. So how do you what's the best practice for declaring variables here? Do you declare them outside of the function and then try to assess them, assign values to them within the function and in the if conditionals and all of that? How do you go about it? Because I'm trying to solve an assignment and the recent assignment that we were given and on building a calculator. So I'm kind of having a bit of challenge there, but I'm still trying to solve it. So I want to know how the best practice for approaching this. Thank you.
All right. So your question is contextual. It depends on what you are trying to do, what you're trying to achieve. All right. There's no silver bullet to this type of question. Well, I will tell you that if you're writing if you're programming, you're applying the functional programming technique, you'll be dealing with pure functions. All right. What pure functions do is that you do not interact with the outside world. That's why they are pure. They don't interact with any other person. They do their thing and give you a result. All right. So what you do in that sense would be to create a variable inside the function. All right, inside the function, and your if and else or whatever could interact with it. All right, that's what I've done. But if you don't care about functional programming and pure functions and all the stuff, right? and your variable has use outside this function, then you'll be creating it outside. For instance, let's say we have a variable called program name, for instance, program name. Program name is calculator 1.0. So this is your program name. In this case, you know that this function has need of program name, but it is not the only guy that will make use of program name. Program name is a general variable that other functions should have access to. Then you'll be creating it outside the function, all right? But if you've done your analysis, your CDO coding and everything, and you discover that, oh, program name has no use outside this function, one function, then it should be inside the function. It has no purpose being outside the function, all right? So when you create variables, basically, you're going to determine the scope based on the use of that variable, all right? If other functions need to have access to it, then why is it inside the function? Okay, if other functions don't need access to it, then why is it outside the function that needs it? All right, so that's it. It's like public phones, right? Public phones do not belong in anybody's pocket. So if you do that, you're stealing. The funds is meant for the public. So why is it in your pocket? All right. But if the funds is yours, then why is it in the street? Why are you leaving it out in the open? You know, it ought to be, in your possession. So that's just it. So based on the use case and the people that need to have access to it, all right, you determine where your variable should reside. Okay.
All right.
So
All right. Thank you.
you're welcome. You don't have any other question?
No, not at the moment.
Okay. So yeah, that's it. So let's talk about callback quickly. Callbacks. You need to remember two things. Is it two or more? Let's see. If we discover more, I'll list them. So number one, functions are first-class citizens. JavaScript. Okay. Two, functions can but like functions can be passed into functions as argument. All right, so let me just say function reference. All right. And another one, okay, let's just leave that two for now. So I'm just gonna say MB functions that receive functions as arguments are called higher order functions. Then the second note I want to take is that functions that are passed into other functions as arguments are called callbacks. Callbacks. All right. So when you see callbacks, we're saying that that function is passed into another function. So you might have encountered the famous set timeout. Set timeout function. The set timeout function takes two things. Number one, the timer handler, and two, the timer. All right. If you want to read more about it, you click on MDN reference to take you to it. All right. So, but the handler is a callback function. I think this documentation has been updated. So most times they will call it a callback so that you see there. All right. But it takes a timer handler and then a timeout. So something like this, you see people often write it like this. You can give it a name if you like. I'm gonna call it greet. Okay, and then the function there, console.log hi, and then I'm going to say 1000 milliseconds, which is 1 second, but let's make it 5,000 so that it delays a bit. So I'm going to refresh this code, wait for 5 seconds, and if everything goes well, we should see hi printed after 5 seconds. Okay, so that is what's happening here. Now, according to the notes that I've left for you here, set timeout is a higher order function. So I said functions that receive functions as arguments. This is a function being called right now. It's not being declared. So let me remove the argument so that you see it clearly. This is a function call, right? We all know that when you use double brackets after function name, you are calling the function. Okay, set timeout is available to us through global object. That's why we can make use of it out of the blue. All right. So it's being called, right? So we're saying that functions that receive functions as arguments, all right? And you know that anything you pass into a function during its call, it's called an argument, all right? So functions we receive other functions as arguments are called higher order function. So set timeout is an example of a higher order function. Again, if you happen to attend an interview and then they ask you, list 4 higher order functions, you should be able to list them because why? You know what a higher order function is, and set timeout is one of them. Okay, and there are many more. All right, so this is it. In fact, if you think back, you remember the map, reduce, so map like this, reduce, right, filter for each. These are all higher order functions because they accept functions as arguments. All right. So that is that about that. Then the second note is that functions that are passed into other functions as arguments are called callbacks. All right. So callbacks are passed into higher order functions. In this case, this function you see here is called a callback. This guy here, because it's the first argument passed in. All right. So that is it. Now we could have, if you check number 2 here, I said function references can be passed into functions as arguments. All right. In that case, this is a function reference itself. Yeah, if you think about it well enough, you realize that it's true. But then if I want to make it obvious, I'm going to get it out of here, put it outside. So this is a function declaration now. And then I'll refer to it by just calling its name. So this is a function reference. This is a function call. You need to know the differences. When you see just the name of the function, we are referencing function. But when you see that it's being executed, that's this, it has these 2 brackets attached to the name. That's a function call. There are 2 different things. All right. What you need is a function reference. So if I save, I will wait for, let's refresh, and 1, 2, 3, 4, 5. Okay, that's 5 seconds. You see that it has been printed to us. All right. So function references are passed into functions as arguments. Okay. So now this is this is 12 already. I begged for extra 15 minutes. I hope that the lecturer is gonna approve. Please guys, if you know that you have another class, just help me. I think we have time. Nice. All right, everybody, just stay with me, okay? All right, great. I've been granted permission to continue. All right, thank you. Thank you. Thank you. Okay, so let's go. Let's be free. So in case you're already getting tired, once I get 4 comments on the chat, that we should stop class, then I would stop, or I just 4 votes and we'll stop. So let's continue now. Now, this is a higher order function that is created and made available to us by its JavaScript language, all right? If I do console the log window, which is the global object, right? You're going to see that it has set timeout somewhere in there. So if we go to S, you should be getting SE, set timeout. So see set timeout here, all right? Everything available in this global object, you can access it without any reference to window. No, please. I'll have to take permission from my bosses. The person that I'm requesting for local recording. All right. So you don't need to, refer to window. We could have done window dot set timeout, and we still get the same thing printed. Okay. Window dot set timeout, we still get the same thing done, which is high printed after 5 seconds. But we don't need this. It's global, so it's accessible by everybody. All right. Now this is accessible to us, but we could create our own, right? Well, because why not? I want to create mine. Okay. So what would I do? We say it's a function, so I'm going to call this function caller. All right. And it's going to take in a function. So this function caller, because it is taking in a function, it is a higher order function. So if you have a question that says, create a higher order function that does A and B and C, you know that it's a function that accepts a function. That's it, all right? So playing with terms there. So functions that passed into the function. So what we'll be passing into it is a callback function. So what this function caller does is simply call functions. So whatever function I pass into it is going to be called. Simple. It's going to be called. All right. So if I come here, I'm going to say, I create a function now. So function greet. All right. And then console.log say hello. All right. And then I'm going to say call, say console.log called by, right? So called by function caller. Okay, so that will know the difference. Now, if I call this, watch now, I'm going to call greet directly. You see that we have say hello printed. But I want to call greet using the function caller. So what will happen is that I will take the function caller and then I will pass greet into it, but not the function call now, not greet as a function call, but greet as a reference. Take note of that. And if I say, you see that it has been called by the function caller, say hello. So that's what you see here. Call by function caller, say hello. So the call happens here, right? So I pass in the reference and then the call happens inside here. All right. So I've succeeded in creating our own callback. So greet is a callback now because it is passed into function, and also created our own higher order function. All right. This is very easy if you always remember that functions are first-class citizens. What does that mean? It means that just the way you have primitives passed around, you can pass functions like that. All right. So functions are values. If you would use that term, functions are just values. All right. They're just a more complex values. Just the way an object is a value, function is also a value in JavaScript. Don't think about it too highly. All right. So I don't complicate things. So immediately you accept that fact, you would accept that because objects can be passed into functions too, since they are also values, they can also be passed into functions. All right. Okay, but in this case, you always remember that you pass the function reference, not the function call. When you are calling a function, you are executing the content of that function. But when you just have the name being referred to, it means that you are referring to the content of the function. Okay? And that should make sense. So having said this, I think this is like what you need to know about function. So let's copy this function. Not this one, sorry. Let's go back to set timeout. Let's go back to set timeout. And we're going to copy this and paste it in our tool, and then we're going to save and run. I'm going to pause here. So see what's happening here. And what's happening here is let's rerun. Pause, right? So you see that set timeout has been called. So set timeout has been called. And that is a function call, right? And we have said that every function call creates a function execution context. And that execution context is added to the call stack. All right. So that's why you see it in the call stack. This is a function execution. All right. So it's in the call stack. Now, what happens is this. This is a web API called set timeout. It's a web API called set timeout. So what will happen is that JavaScript is going to move it into the web APIs. I'll call it compartment for now, all right? Or there's an engine that deals with web APIs, all right? So immediately it enters the cluster. JavaScript knows that, oh, this thing is something that the web API should handle. So it pushes it over there. So if I'm going to play now, resume, and pause, you see that it's now in the web API section, all right? And what is there? Whatever it is going to execute has been put there. And it knows that, oh, this thing has a timer that is going to elapse in 5 seconds. So that's this green that you see here rolling. So if I resume, you see it's going to roll, and when it's 5 seconds, it is going to be put inside this callback queue. So if I play, it will put into the queue, and if I pause, you see that it's in the queue now. And it's going to look at this call stack and say, is there anything currently running in the call stack? If yes, it will be pushed into that course, and it will stay, it won't be pushed. But if no, it will be pushed into the call stack. And then it's going to run, execute its content, and then exit. All right, so I'm going to rerun and pause. So now let's go back to our code and examine something. Stay with me. So this is set timeout. This thing happens almost every time in programming interviews. All right, depending on the role you are applying for, though. So they're going to give you something like that. Say console.log. Hi, I am here. And then after the set timeout, they give you another I'm here in the future. And then they're going to ask you, what do we see in the console? Okay. So what they're expecting you to do is to tell us the order in which these are going to occur in the console. All right. Now, if you think about the fact that JavaScript runs from top to bottom, what you would see is this. You would say that, first of all, we'll have hi, right? I am here, first in the console. Second, we have two, hi, which is this greet, because greet is being executed here. And three, we'll have this one here. All right. This would be your answer. Okay. When you are thinking about the fact that JavaScript runs from top to bottom. But if you try to be very smart, you now realize that, wait, this guy is going to run. This guy is going to run after 5 seconds, right? Because we have said that grid should run when this time elapses, which is 5 seconds. And before that time, this should have run now, right? Or if JavaScript runs synchronously, that means this would wait for this to happen. In fact, no, this third line will wait for this to happen. Okay. But then you have the idea that JavaScript does not run synchronously. JavaScript does some tricks to look asynchronous, right? So you say that what will happen is that this would come second, it's 2, and this will come third, it's 3. Well, this is correct, but not so correct with the way that I thought about it. So let's save and refresh. So we see I am here first, I am here in the future second, and third high. All right, which we did save and it's correct. Well, I think so. Because of the way you thought about it, like the pseudo code that went on in your head, you think that this is correct. But what happens if I say 0? If I say 0, what happens? Okay, like 0, what happens? Then you think that, oh, this runs immediately, right? Because it's 0 millisecond, that means it's immediately. So therefore, this should be second, and this should be third. But to your greatest surprise, you see that it is still third, right? Even if this should run immediately now. Why? What happens? It is because of what I showed you here. All right. So what I've shown you is that the way JavaScript runs is this. Everything in the core stack, right, has to finish first before anything you have in the callback queue is considered. All right. So now let's go back from top to bottom again. I'm going to refresh this page. All right. And I'm going to bring this code here. Not bring this code here. Okay. And then let's see. I'm going to pause. I missed it. Refresh. Pause. Gosh. Okay, we run pause. Yeah. Okay. So we see we have hi, I am here. Okay, that's the first guy. Quite all right. I am here. All right, and then it is popped up the stack. And then the second guy is set timeout. All right, it's called. Now, set timeout is not a natural JavaScript phenomenon. Phenomenon. All right, so what happens is that it's a web API, right? So it gets shifted to web APIs. And then, so let's go. Let's save and run. See set timeout now. If I play, it goes to web APIs. I mean, immediately it is fulfilled, it passes it to the callback queue. Now see what's happening. Console.log, this one you see here, is in the callback queue. So is in the call stack. So this callback queue content cannot run until the call stack is empty. All right. So that's why you see that. If I resume, this is going to be popped, console.log is going to be popped up the call stack before greet is now put in the call stack. If I resume, you see that greet has been put in there. So greet will now execute its own content, and then that's why you get that result. Okay. So that is something that you need to know. If you are dealing with web APIs or asynchronous code, you would need to understand what's happening behind the scenes. So when we get to async in JavaScript, we'll come back, we'll revisit this concept, right? And then understand for that. But when you talk about callbacks, this is what will mostly happen, especially if you are dealing with web APIs. So I thought that I should bring that to your notice. Okay. Now I want to give you a consolation. I like giving my students this consolation. A lot of the things that I teach, or that I've been teaching now to this point, you can do without them. It's very hard to say, but yes, it seems like bad advice, but you can do without them. Why? You can be mediocre,
All right. So, and a lot of developers they really don't know these things, and they might be working somewhere and then they're making some money, right? But if you are going to be a good JavaScript developer, you don't want to do without them. All right. So I'm saying this to say that some of these things might not come to you naturally the first time they are being taught, but I promise you it happens to the best of us. I'm explaining these things off the top of my head now. It seems like, oh, this. But it took me years. All right. So it took me years. So I'm explaining it now. It looks like play and everything, but trust me, they did not bomb me with this thing. They get me. I had to learn, I had to read about it several times before it stuck. All right. And the same can happen for you. All right. And then you need to be very inquisitive. Don't just attend the class, wait for the next class, or just watch videos. Go online. All right. Read about don't get lost. When I say go online, online is a sea of information. You can get lost. All right. You can get caught up in just learning, and not really doing anything substantial. That's why I would say you can stick with our course curriculum and then learn deeply every topic that's in the curriculum because it was carefully selected. It's going to build your knowledge, in an aspect of this programming thing, all right, which is the NodeJS, the backend aspect, and then you'll be good at it. So you'll not be lost to just learning and learning and learning like that. So based on the course curriculum I've released, you can search deeply, or based on every class, you can go and then watch concepts. So I'm giving you all these terms: first class citizens, function references, higher order functions, and then callbacks. All these are terms, all right, that are hidden in this thing that I just dropped here. You can be smart enough to pick out some of those terms and then read more about them. Like, what does this mean? What does this mean? References, what does it mean? All the stuff. You will discover that you will be better than a lot of developers. All right. And one thing is sure, in this programming world, overtaking is allowed. So for the fact that I'm teaching you today, does not mean that you cannot be better than me in even what I'm teaching you in the next 1 year. It is very possible. Because you might go deeper than me, you might use it more than I do, right? Especially for people like us that we're already working for a company. Sometimes we're stuck in what we already know, just repeating it for the company, and you're enjoying yourself, you're doing something. But then there's somebody out there who is learning more. So I say this also because there are some students that will be like, oh, more, when have we reached this level? Trust me, it depends on you. All right. That question depends on you. All right. So if you take time to learn these things, all right, and to practice them and to do them, the secret is in doing, not just learning. And you do them, you discover that you will shock yourself at how good you can be. Okay. So at this point, I'm going to refer you to some resources. If you're somebody who reads PDF, look for, you don't know JavaScript yet, look for this PDF series by Getify. I hope I spell his name well. Either one T or double T. Double T looks like one T. All right, so look for this series. What was that his name again? Kyle Simpson. Simpson. Correct. Okay. So you don't know JavaScript series, PDF series by Kyle Simpson. Read it. And if you finish this book, you already know JavaScript more than I do. Trust me, because I read it, but I did not finish the series. So if you finish the series, I don't just mean finish, I mean like you know what you read. I should be coming to you for lectures. There's a lot that's packed in this book. A lot that's packed in the book. So you can read it if you are the reader type, and it's going to help you a lot. All right. Yes,
Hello.
the PDF. Yeah, go ahead.
Yeah, so please, I have a question. So in number 2, where you mentioned the function reference can be passed into functions as arguments. So I want to know, how does JavaScript implement it when you are using an anonymous function that doesn't have a name? For example, using arrow function, passing arrow function as arguments. So how does the referencing work there?
All right. So that question is very important. So you see, let's write something again now. So set timeout, okay? And then this is what you're talking about. This is an arrow function. And it's under 5,000 milliseconds. This is an arrow function. If we check, we should see after 5 seconds, hi should be printed. All right. So this is what we call an arrow function. And it is anonymous because it has no name. All right, English. So if I bring it out of here and put it here, you see that it has no reference. The reference is a name in that sense, right? It's a name that refers to something. All right. So that's the reference. But if I want it to be referable, that means I want to give it a reference, I could just say hi. Of course. So I'm just giving it a reference, and then I copy that name and put here. Now, without explaining anything, are you able to understand what's happening? Are you able to understand? What's happening is that this guy you see here is a value. You need a name to that value. You need a name to refer to that value. But if perhaps you don't really need a name, you can simply take the value and put the value here. All right. Are you getting the concept, HP?
Yes, I am.
So that's just it.
Okay. I mean, inside the web API, how does it put the whole code, the whole function there, as the whole arrow function inside that web API, and then there was those movements and this one going to this
Yes.
place and
So
that.
I don't know what to call it, right? We can try because the tool is there and our laptop will not explode. So why not try? So let's try also. So set timeout and then let's see, we run. Oh, there is grit. No, I'm not talking about grit. So let's paste this guy. Yes, save arrow. So let me refresh. Let's see. Because some funny thing has started happening. So save around.
Okay.
So I don't think the tool is optimized for that. I don't know why. I'm trying to save and run, and it is giving me something else.
Okay.
It will not be optimized for that. But then the concept is what is important, right, for you to get. So reference is just simply a name we're using to refer to something. Okay. So let me show you something, right? There's a concept called is it IFI? Yeah. Merely invoked functions. How it is spelled now, I've forgotten. But let's learn the concept. So see this function here, right? I'm going to copy this function out and put it here. let me this. So you see this function here, it will never run. If I refresh, it never runs because this is a function declaration that has no name to it and it's not being called. But I can call this function if I want. So how do I call it? I'm going to enclose this function in a bracket. Now this resolves to a value. Remember that functions are values, right? So this resolves to a value. And then I'm going to call the value that it resolves to like this. If I save, see that hi has been plugged to the console. It means this is now executing. So I am calling this function. That's what's called the immediately invoke function, if is. All right. So I've called this function and it's not running, even though it is anonymous. What I did is that I immediately invoked it. I wrapped it in a bracket. So what that happens is, remember, BEM does B-E-M-E-S. All right. If you have a bracket in any expression, that bracket is going to be resolved first. All right. So because of that, you see that this bracket will be resolved first. And when this bracket resolves, what does it resolve to? It resolves to this function as a value. All right. And then that value is now being called. So that's why if is I think that's why they can work. All right. So when you have anonymous functions, they are just function values. All right. So you can decide to give it name. The name is so that it can be referred to. All right. But if you have no reason for it to be referred to, you can omit the name and use the function like that. Okay. So if you understand, the key is in understand functions as first-class citizens. If you understand functions as first-class citizens, all these things will make sense because the only difference between a function and every other first-class citizen is that a function can be called. So that's why when you read some tutorials, functions will be called callable objects because they can be called. Other values cannot be called. Objects cannot, like the normal objects you know, cannot be called, but functions can be called. So they are called callable objects. If you see callable objects anywhere, they are talking about functions, as long as JavaScript is the context. All right. So that is it. All right. So JavaScript is very sweet and easy. As long as you know what is at play, you know the various principles and you know what's happening around everything, it's going to make more sense. Okay. So because I think if we don't have more questions, I'm going to end the class at this point. I'm going to end the class at this point. And the next time we meet, we're going to be talking about some, let's say, as async await. We'll just talk about promises and async await and all these things. We'll deal with those guys. And then I think the last thing we'll be doing in this, before we get into real Node.js implementations, would be using fetch, right? Like doing some API calls. All right, so if you have questions, I'm going to take them. Apart from that, you're welcome, Kanye. If you have questions, I'll take them now. If there are no questions, we would end the class. All right, Dominic. Thank you. Okay, guys, let me look at my timetable to be sure. All right, guys, thank you for your time. I hope that the class was helpful. I'll see you guys on Monday. Have a nice day, everybody.
Thank you very much, sir.
See you.